Hello again, welcome back guys. So this is question number 12 of our book, and in this circuit we are given a very simple series configuration of the two resistors in which the source voltage is known, which is the RMS value, and similarly the scope or the oscilloscope is also connected here across this 80 ohm resistor, and from it we have seen that the calculated peak to peak voltage it has is 45.27 volts. So what is the peak to peak voltage? So let us have the voltage waveform across this resistor is basically this one. Okay, so this is the VP while this is the minus VP. Okay, so this VPP is basically this peak to peak voltage, which is this V peak to peak, and we have known it, and this is given here. Okay, as this is a symmetrical waveform, so in order to find the value of Vp from these type of waveforms, what we have to do, we have to divide our peak to peak voltage over 2. Okay, so in the symmetrical waveforms we will get the peak values from this expression, and it will be writing 45.27 divided by 2. We will get how much? 45.27 divided by 2. This will be 22.6 volts. So that is the peak waveform. Just you have to remember that this formula is valid for all the symmetrical waveforms. And what are the symmetrical waveforms? The waveforms where the DC term is this 0 volts, okay, or which originates from the origin and get back to origin. Okay, so this is the symmetrical waveform where the values at the positive cycle are equal to the values in the negative cycle. Okay, so in that case we have this peak waveform. So in that case our peak voltage value is the half of the peak to peak value. Okay, so we have calculated it. After it, you know that this is the peak value here, so we have to find the RMS value from it, because all the calculation here will be done in the form of the RMS or the effective value. So RMS of this value, or let me call it V80. So 80 here is 22.6 divided by square root of 2. Okay, so now calculating it here, what we will have, let me use it, 22.6 divided by the square root of 2. So it will be 15.9, and that is almost equal to the 16 volts. Okay, so here we have this value. Now as we know the value across this resistor as well, and in order to find the value of this resistor, what we can do, we actually have the voltage across this one, and I have earlier told you with every element we have three quantities associated with them, what are basically the current, voltage and impedance. Okay, so if any two of those are known, we can easily find out the third one. Okay, so here we don't have the current, we don't have the voltage, and we don't have the impedance or the resistance here as well. So what we have to do, first of all we have to find out the voltage, and from the voltage we have to find out the current, and after the current we can find out the value of impedance. Okay, so that would be a very lengthy process. As we know the voltage across this 80 ohm resistor, in order to find the value of this resistance here, we can here use a trick in which the value of R will be included and all the other quantities will also be included. So we can use here the voltage divider law at this resistor. Okay, so in order to find the value of V80, we have the voltage divider law, in which which the value of the resistor across, we want to find out the voltage is known, and also the summation of all the resistors which are connected in series multiplied by the total voltage. Okay. So, that is known here. Do we know the value of V80? Yes, we also have the value of V80, and that is 16. So, 16 is equal to the 80 multiplied by 20 divided by R plus 80, or that is 16 R plus 80 is equal to the 1600. Okay. Now, in order to find the value of R, let me simplify it, and it will be R equal to the 1600 divided by 16 and here minus 80. So, this will be cancelled out, and here 100 will be left out, and here R will be equal to the 100 minus 80. So, the value of R will be equal to the 20 ohm. Okay. So, that is the value of the resistance which we had to find here. Okay. And this is the method which we have used, and a very convenient and a very shrewd trick which we have used here in order to find out this value. So, this is basically the concept that how you can use other methods in order to find the quantities by using the concept of the other techniques which we have so far seen. Okay. So, thank you so much, and I will see you with some more tips, more tricks, and more solutions of the circuits like this one in our upcoming video. Thank you so much.